We are here for lesson 9 and 10 together. Multiplication and division rules, factor exchange, and area conversions. So we're going to do lessons 9 and 10 sort of together here because they go together. Okay. Let's start by multiplying and dividing some numbers that have matching signs. For instance, 5 times 2, that's just 10. Negative 3 times negative 6, that's 18. Let's go down below and try 72 divided by 8, that's 9. And let's skip 6, go to 7, negative 90 divided by negative 9, that's 10. Notice one thing about all of these answers to these problems, or these two products and these two quotients. Notice that they're all positive. And the reason being was because I multiplied or divided two numbers whose signs always matched. So when performing multiplication or division and the signs on the numbers are the same or they match, the product or quotient is positive. When the signs match and you multiply or divide, the product or quotient is positive. Okay. The opposite of that is if the signs don't match, say negative 3 and 5, multiply them together, we get negative 15. But negative 8 and 3, multiply them together, you get negative 24. Some division now. Whoops, let's get on the screen there. Here we go. Some division. 56 divided by negative 8, that's positive 7. I'm sorry, no, that's negative 7. That's a mistake. 56 divided by negative 8 is negative 7. And finally, negative 32 divided by negative 8 leaves us with a negative 4. Notice that these signs on the original numbers never matched. When performing multiplication or division and the signs on the numbers are different, the product or quotient is negative. And that's the most important part on the front page to be able to get a grasp of. Okay. Multiplication is a special operation where it doesn't matter what order you perform it. We could say A times B is the same thing as B times A. We could also do the exact same thing with all 6 combinations of A, B, and C. And I'm not going to go through and read these. You could read them yourself. What we are going to do, though, is exercise what's called the commutative property of multiplication. That just means it doesn't matter what order you multiply, just as long as you perform the operation. So what we're saying here is 7 times 5 is the same exact thing as 5 times 7. 4 times 3 is the same thing as 3 times 4. And finally, 2 times 9 is the same thing as 9 times 2. All we're trying to get across here is it doesn't matter what order multiplication takes place. The next part discusses solving for variables using opposite operations. We have 4 main operations we're going to use all year: multiplication, division, addition, and subtraction. Multiplication and division go together and are opposite operations. Addition and subtraction also go together and are opposite operations. You use one to undo the other. Division undoes multiplication, subtraction undoes addition, and vice versa. Multiplication will undo division, addition undoes subtraction. Let's watch. 7x equals 49. Well, I'm multiplying here. So what I want to do is get this x by itself. In order to do that, that 7 has to leave. Well, if I'm multiplying, I need to divide both sides of my equation by 7. These 7's will go away, and I'll be left with x equals 49 divided by 7, which is an easy 7. A quick check shows us that 7 times 7 is indeed 49. So we did that one correctly. Here, we have 32 divided by x equals 8. What we want to do is figure out what number I would divide 32 to get 8. Well, notice I want to get the 32 by itself. to sort of set up a equation. So what I have here is 32 equal 8. And then I want to multiply both sides times x to get this x with the 8 over here. So now I'm left with 32 equal 8x. And now in order to solve that, remember, just like before, I'm going to divide both sides by the number in front of the letter. And 32 divided by 8 leaves me with a 4. So 4 is equal to x. Here is a more complex example. First, I have to get rid of the 9, so that I'm left with just the 4x, and then I need to get rid of the 4, so I'm left with just the x. So the first thing I'm going to do is bring the 9 over here and subtract. Opposite sign here. I was adding, now I'm subtracting. So 4x equal 29 minus 9, which is just 20. Divide both sides by the number in front of the letter. X is equal to 5. The next one we'll try is 5x minus 7 equals 2x plus 2. What I need to do first is get the letters together and then the numbers together. So I need to put these two guys together, and I need to put these two guys together. Okay. In order to do that, we need to exercise a little thought process called change sides, change sign. Here's 2x here. I'm going to bring it over here. It was a positive 2x, but when I bring it over here with the 5x, it's going to become a negative 2x. Same thing with this, negative 7. I'm going to bring it over here with the 2, and when I change sides, I change sign. The 2 is already there. Now it's 2 plus 7. Now we just put things together. 5x minus 2x is 3x, and 2 plus 7 equals 9. My last step is just to divide both sides by the 3 in front of the x and remain with x equal 3. Okay, here's what I would like for you to do. I would like for you to try number 5 and number 6 on your own, and we will start the next class period with those. One more thing that we need to do in this lesson is called conversion of area. And before we do that, we need to review conversion of distance, or one-dimensional measures. So we're going to convert 5 meters to inches. Remember, always start with what you know over 1. So 5 meters over 1. We need some conversion factors here. The first thing we need to know is that there are 100 centimeters in 1 meter. And we should also point out that there are 2.54 centimeters in 1 inch. Those are going to be critical to our ability to complete this. Okay, our next step, since we have meters up here, we know meters have to go down here. And first, we're going to look up here at our conversions and see that meters go with centimeters. So centimeters has to go up here. Times, now that I know centimeters are up here, centimeters have to go down here. I already used this conversion once. I'm not going to use it again. So I look at my next conversion and realize that centimeters can also go with inches. That's why we put inches up here. Now let's go back and fill in our numbers. When centimeters are with meters, there's 100 centimeters in 1 meter. Now, when inches are with centimeters, there's 1 inch in 2.54 centimeters. Remember, it's okay if you just multiply straight across and leave the numbers like this. I'm okay with that. And this is good enough for a final answer. Now, if you want to multiply this out and get 500 up here and then divide by 2.54, that's fine. But remember, that's good enough. Now, area takes into account 2 dimensions. The measurements are squared for that reason. So our first example is going to be convert 2 square miles to square feet. Always start with what you know over 1. I'm going to see if I can get both of these in the shot here so we can compare what they look like. Okay, so 2 miles squared over 1 to square feet. Here is our conversion factor right here. 5280 feet equals 1 mile. Multiply by our conversion factor. 1 mile is 5280 feet. But the difference is we have to do this conversion again because this is square miles and this is only regular miles. So we have to do the exact same conversion again. Basically, what you need to remember is that when you convert areas, you have to do the simple conversion twice. Our final step is just to multiply straight across the top 2 times 5280 times 5280, and that's all over 1. Okay? Now, on the bottom of this page are 2 more examples that we'll also explore in class. This concludes what we are going to do for lessons 9 and 10. Make sure you try these 2 examples on your own, and we will start there in class.